Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year June 2008 paper 2. There are 50 questions in this paper. So we covered already the first 25 questions in part 1 video, and the remaining 25 questions we are going to discuss in this part 2 video. I will explain all the concepts in simple terms and provide tips and tricks to help you ace the exam. So whether you are a beginner or an experienced one, this video is for you. So let's start the video. The ATM cells are how many bytes long? So given the question, the ATM cells are dash bytes long. So actually in an ATM, it consists of a 5 byte header. So 5 byte header and a 48 byte payload. So that is totally, so we have totally 53 bytes. Therefore the ATM cell size is 53 bytes long. So with the 5 byte header and 48 byte payload. The answer is option B. For slotted Aloha, the maximum channel utilization is. So these type of questions are normally asked in NET and GATE exams about the pure Aloha and solid Aloha. So what is the efficiency of pure Aloha? So what is the efficiency of solid Aloha? What is the maximum channel utilization of the solid Aloha and pure Aloha? So these type of questions will be repeating in the exam. So normally the throughput of the solid Aloha is G into e power minus. The throughput is G into e power minus G. The maximum throughput is 1 by e frames per frame time. So which is approximately 0.368 frames per time. Okay. So 0.368 frames per time or 36.8%. So this is the maximum channel utilization of the slotted Aloha. In the slotted Aloha, there are discrete time slots. So option C is the correct answer. For a channel of 3 kHz bandwidth and signal to noise ratio of 30 decibels, the maximum data rate is. So we need to find out the maximum data rate. So normally, so there are two types of formulas here for finding out the maximum data rate. So we have to find out whether it is a noisy channel or noiseless channel. So here we have signal to noise ratio. That means it is a noisy channel. Okay. So for noiseless channel, the formula is different. Okay. So we'll see in detail about this question here. Since it is a noisy channel, the maximum data rate for a channel is calculated using the Shannon's capacity. So the Shannon's capacity formula is B log base to 1 plus signal to noise ratio. Okay. So here the C stands for channel capacity and B for bandwidth of the channel and signal to noise ratio. So here it is in the format of signal to noise ratio form, not in decibels form. So we have to convert the decibels into signal to noise ratio form. So first of all, so what is the bandwidth here? Bandwidth is given as 3 kHz, right? Bandwidth is 3 kHz. Signal to noise ratio is 30 decibels. And so we need to find out the maximum data rate. So bandwidth B equals to 3 kHz. So we are converting the kilohertz into normal hertz formula. So we know that 1 kilohertz equals to 10 to the power of 3 hertz. So we are multiplying the 3 into 10 to the power of 3. That is 3000 hertz. So we are converting the kilohertz into normal hertz form. Next, signal to noise ratio in decibels. So in decibels, it is 30 decibels. So we are converting the decibels to a linear scale form. The signal to noise ratio linear scale form, we are converting it. Okay. So here given the 30 decibels. So here signal to noise ratio linear form is equals to 10 to the power of signal to noise ratio decibels by 10. So signal to noise ratio decibels is 30 decibels. So 30 by 10 is 3. So we have 10 to the power of 30 by 10, that is 3. 10 to the power of 3. So we get the signal to noise ratio in linear form as 1000. Now substitute the value in the given formula here. C equals to 3000 log base to 1 plus 1000. That is equal to 3000 log base to 1001. So if you substitute this formula, after approximating we get the answer as 30,000 bits per second. So the main thing that we have to remember is, so we have to check out whether the given problem is about a noisy channel or noiseless channel. Okay. So the correct option is option D. Next. An example of a public key encryption algorithm is. So here the Caesar cipher is one of the simplest form of encryption. AES and DES algorithm are symmetric key based encryption. So here all the options follow. With reference to hierarchical routing, the optimum number of levels for an M router subnet is. So the answer is root M. The answer is root M. So in hierarchical routing, it will reduce the number of entries that were entering into the routing table and optimize the lookup time. That means it will reduce the search time. So we are reducing the number of entries in the table. That means obviously we are reducing the time for searching the entries. The number of hierarchical levels is determined by minimizing the total cost, which typically includes the memory cost for routing tables and the processing cost. So if you are minimizing the total cost, that means so we are if the number of entries are minimal, that means the memory cost is also minimal, right? That means we are reducing the number of entries. The memory cost will be decreased, and similarly here the processing cost will also be reduced at each level. So for a network with M router, the optimal number of levels is in hierarchical routing is proportional to root M. This ensures a balanced trade-off between the routing table size and lookup time. So option D is the correct answer, that is root M. Assembler program is. So whether it is dependent on OS or it is dependent on compiler, it is dependent on hardware or independent of the hardware. An assembler translates the mnemonics such as jump, move, add, etc. from an assembly language into instructions format. Machine instructions are entry dependent on the hardware. So they represent the hardware or CPU instruction set. So that's why assembler program is dependent on the hardware. In the indirect addressing scheme, the second part of an instruction contains. So first of all, what is meant by indirect addressing scheme? In indirect addressing scheme, the address field in the instruction contains the memory location or register where the effective address of the operand is present. So here it requires two memory access, that is register indirect and the memory indirect. So here the effective address of the operand is the contents of the register or main memory location, whose address is given in the instruction. So here the effective address is stored in the memory location and it is pointing to the again another operand here. So that means there is two memory references in the indirect addressing mode. First for the register reference, and the second one is the memory address given in the instruction parenthesis. So that there are two memory access. So option C is the correct answer. The address of the location where the address of the operand is stored. At the end of parsing, so what will happen? At the end of the parsing, tokens are identified and a parsing tree is drawn. But that one is not given here. So that's why none of the options are correct. So in the lexical analysis, tokens are identified, and in the parsing, it will generate a parse tree. But that is not mentioned here. So none of the options are correct. Dead code elimination in machine code optimization refers to. Dead code elimination is a compiler optimization technique which is used to remove code which doesn't affect the program result. That means removal of values that never get used. So here we are removing some dead code from the program, so which is never used from the program, so that we can easily run the program within less time and with less space complexity. So that's why option B is the correct answer. That is removal of values that never gets used. A parse tree is an annotated parse tree if it shows attribute values at each node. There are no inherited attributes. It has instead nodes as a terminal nodes. Every non-terminal node is an inherited attribute. An annotated parse tree. So it is a parse tree that shows the values of the attributes at each node. The process of computing the attribute values at the nodes is called annotating or decorating parse tree. So option A is the correct one. It shows the attribute values at each node. Next. An example of a non-preemptive scheduling algorithm is. So these types of questions are also repetitively asked. That is the CPU scheduling algorithms. So there are two types of algorithms. That is the preemptive algorithms and the non-preemptive algorithms. So preemptive algorithms are some of the preemptive algorithms or round robin scheduling algorithms, shortest remaining time first algorithms, so like that. And non-preemptive algorithms. So what is the preemption, non-preemption? So preemption means interruption. Non-preemption means without interruption. An algorithm, a scheduling algorithm when done completely, it will execute the particular program completely without any interruption. That is called as a non-preemption. Preemption means there will be some interruptions. Suppose if we take the round robin scheduling algorithm. In the round robin scheduling algorithm, there will be some time quantum. That means a time slice is given and the program is only executed for that amount of time. And the remaining time the CPU will do other tasks. Right. So that means there is some interruption in the algorithm execution. But here non-preemptive algorithms, you have to find a non-preemptive algorithm. That is the option A is the correct one. That is shortest job first scheduling algorithm is a non-preemptive scheduling algorithm. Okay. And preemptive version of the shortest job first is the SRTF, that is the shortest remaining time first algorithm. That is the preemptive version of the SJF algorithm. So option A is the correct answer. That is the non-preemptive CPU scheduling algorithm. Next. There are n processes in memory. A process spends a fraction t of its time waiting for input-output to complete. The CPU utilization is given by. So there are n processes in the memory. So that means there is a n number of processes in the memory. A process spends a fraction t of time. So it spends a fraction t of time waiting for input-output to complete. That means totally it takes p to the power of n time. Right. So now the CPU utilization is given by 1 minus p power n. So option. So 1 minus p power n, that is option D is the correct answer. So here we are assuming that the processes are independent. An example of a memory management system call in Unix is. So mmap is the memory management system call in Unix. Mmap is a POSIX compliant Unix system call that maps files or devices into memory. It is a method of memory mapped file input output. It naturally implements demand paging because file contents are not read from disk initially and do not use physical RAM at all. Whereas fork means creating a new process. So we are creating a process here, new process here, that is called as a fork. It is usually a system call implemented in the kernel. And signal action. So it is a function API defined by POSIX to give programmer access to what should be program's behavior when receiving specific OS signal. So option D, that is nmap, is the correct answer. A 64-bit virtual address, a 4 KB page, and a 256 MB of RAM, an inverted page table has a number of entries. So here given the page size and virtual address size and RAM capacity. Okay, so all these things are in different format. Okay, so first of all, what is the given RAM size here? 256 MB. So if you convert it into the bit format, okay, that means 2 power 28. Okay, 256 MB equals to 2 power 28. How it is possible? So normally MB means 2 power 20, right? So MB means 2 power 20 into, so 256 can be written as 2 power 8. That means 2 power 28. So there are 2 power 28 bytes in the RAM, allocated to the RAM. That means we have 28-bit physical address. So here 28-bit physical address. Next, given page size is 4 KB. That means if you convert into the byte format, 4 KB means 2 to the power 2 into 2 to the power 10. That equals to 2 power 12 bytes. So it is of a 12-bit page size. So physical address is 28-bit and page size is 12-bit. So 12-bit page size. Next. So we need to find out the table, number of entries required in the inverted page table. So in the inverted page table, total number of entries is equal to total number of page frames. So that's why the total number of page frames here is RAM size by page size. So what is the RAM size? 2 power 28 by, and page size is 2 power 12. Okay, if you solve this equation, we will get 2 power 16 bytes. That is 65536. 2 power 10 is 2 power 16 is 65536. So that is the answer. Number of entries in the inverted page table. Next. A computer has 6 tape drives with n process. So here the number of process are, so here P number of process and the tape drives, that is the resource is 6. The number of resources are 6. Each process may need 2 drives. It needs 2 drives here. Okay. So for which values of n is the system deadlock free? So we need to find out the for which value of n the system is deadlock free. So for this, to find out the deadlock free situation, we have some formula that is called as r greater than or equals to p into n minus 1 plus 1. So here the p stands for the total number of process, and r for total number of resources, and n for need of each process. So what is the number of process here? So n into, so need is 2 minus 1 plus 1. So r is 6. So 2n, so that is 1. 2 minus 1 is 1, right? So n plus 1. So 6 greater than or equals to n plus 1. So that means 6 minus 1 is 5. So 5 greater than or equals to n. That means n value must be less than or equals to 5. So then only it will be deadlock free. Okay. So therefore total number of processes cannot be more than 5. So here in the given options 5 is not given. So the maximum number of the maximum value here given is 3. So option C is the correct answer. Waterfall model for software development is. The waterfall model is a sequential approach. So it is a non-iterative design process used in software development process in which progress is seen as flowing steadily downwards like a waterfall. So from top to bottom, right? Through the phase of conception, initiation, analysis, design, construction, testing, implementation and maintenance. So it is a sequential approach. Option C is the correct answer. In software development, value adjustment factors include the following among others. So value adjustment factor is equals to TDI, that is a TDI into 0.01 plus 0.65. So this is the formula of the value adjustment factor. So here TDI stands for total degree of interface is the sum of values of general system characteristics. So here the option A is the correct answer. There is the criticality of the performance and reusability of the code. While designing the user interface, one should know. So they must use as many shortcuts as possible, or they should use defaults as possible, or they must use as many visual layouts as possible, or to reduce the demand on short-term memory. So option A is the correct answer. So while designing a user interface, we must use number of shortcuts as possible. So reducing the demand on short-term memory will be helpful in designing the process of a user interface. In software cost estimation, base estimation is useful. Cost estimation model uses a basic regression formula with the parameters that are derived from historical project data and current as well as future project characteristics. So we are using the cost estimation model to find out the cost of a similar project already completed. So option A is the correct answer. In clean room software engineering, what we will do? Clean room software engineering is a software development process designed to produce a high reliable software with minimal defects. It mainly focuses on preventing defects rather than fixing them after testing and aims for near zero defects in the final product. So here the name is denotes clean room. That means it is very clean. The room is very clean without any defects. Okay, so there is no dust or anything in the room. So it is very clean, and so all the problems are we will focus on preventing the defects rather than fixing them after testing, and we aim for a near zero defect. The main advantages here are high reliability, cost effective, predictable quality and structured development. So option D is the correct one. Implementation is done only after ensuring the correctness. So it is reliable, and after preventing a defect, the implementation is done. And clean room software engineering is a development process. Amdahl's law states that the maximum speed up F achievable by a parallel computer with a pre-processor P number of processor is given by. So what is the Amdahl's law? It is used to model the performance improvement of a system when a portion of the system is enhanced such as through parallel processing. It shows the theoretical maximum speedup that can be achieved by optimizing only part of the system, given that some parts of the system remain serial. So here S is given as S equals to 1 by 1 minus F plus F by P. So here S stands for the speed up of the system, and here F stands for the portion of the program that can be parallelized, and 1 minus F it will denote that the proportion of the program that is serial, that means which cannot be parallelized. So it is so we cannot parallelize this type of thing, and it is the parallelized is called as F. And here P means the number of process or units of parallelism. So option option D is the correct one. F less than or equals to 1 by 1 minus F plus F by P. With reference to cluster analysis in data mining, a distance measure that is not used is. Option D is the correct answer, that is the lead distance. Lead distance is applied for phase modulation, while the Hamming distance is used in the case of the orthogonal modulation. So that's why lead distance is the correct answer. In a mobile communication system, a geographic region is divided into cells. For each frequency set, there is a buffer dash wide where that frequency is not used. For each frequency set, a buffer 2 cells wide in which that frequency is not used. That is option B is the correct answer. Identify the incorrect statement. So here the overall strategy drives the e-commerce data warehousing strategy, which is correct. And data warehousing in an e-commerce environment should be done in a classical manner, this is also correct. And e-commerce opens up an entirely new world of web servers, so it is correct. And option D is the wrong, right? It is an invalid statement. So that's why option D is the answer. Identify the incorrect statement. So here the question is given on the ATM, right? So about the first is the ATM adaptation layer and logical connections in the ATM, and ATM about the ATM cell relay. So these are the statements given. So here option A is the correct answer. Sorry, the correct answer. Why? Because it is the incorrect statement. The adaptation layer defines how to segment and reassemble higher level packets into ATM cells, and how to handle various transmission aspects in the ATM layer. The main services provided by ATM adaptation layer are segmentation and reassembly, handling of transmission errors, handling of lost and misinserted cell conditions, timing and flow control. So option A is the invalid statement. So this is about all the questions in the part 2. I hope you have learned something from this video. So please do watch, like, share and subscribe to my channel. Thanks for watching.